Hi, and welcome back to this series. In the last episode, we started with this completed box. Next, we switched to the box layout complete with spreadsheet. We punched in our calculated values, and 1 minute, 6 seconds later, we had the finished model. Then we exported to an STL file, and it was off to the 3D printer. As promised, today we're going to dive into parametric programming and show you how to create projects like this of your very own. Just remember what I said. Once you create a file like this, you never have to suffer the drudge work of creating another Enclosure program again. Ever. We're now looking at an empty project with just the spreadsheet we created for my Enclosure. Obviously, if you're starting from scratch, you will need to populate a sheet of your own. To do this, you'll need to go to the drop-down menu and select the Spreadsheet Workbench. From the toolbar, you'll need to press the Create Spreadsheet icon. Then from the model tree on the left, select the new spreadsheet. As you can see, a new spreadsheet has popped up ready to populate. Since I have no doubt that you've used spreadsheets before, all I'm going to say is there are no real surprises with this one aside from what I'm going to show you with mine. That said, we'll now delete this one and get back to mine. We're now back to my original sheet, and as I've said before, provided you accept the default values, the top 4 dimensions are all you need to change to create a new Enclosure. That's what makes parametric programming so crazy simple. When doing parametric CAD, I always begin with a spreadsheet. During the design process, instead of referencing the cells by row and column, I always create an alias for every cell I'm going to reference. Let me show you how I do this. First, you select the cell, then right-click on it. A notification pop-up that says Properties. Click on it. A new menu comes up allowing you to modify the cell's properties. There are 5 tabs along the top of this menu. We're going to click the Alias tab at this point. A text box is displayed asking you for an alias name. For the sake of organization, I've adopted the convention of having the first letter in the alias to be lowercase. As you can see here, the with alias is the same name as the human readable label in the cell A1. I also want to suggest that you don't let these alias names get too long. Abbreviate as much as possible, as these alias names will be appearing in the cell formulas you create. We'll click the OK button to accept the alias values displayed. Also notice that all of the cells with alias names are coded with the color yellow. This does make these cells easier to spot when you're composing formulas appearing in other cells. As you no doubt know, spreadsheets are living documents. When programmed, a change in one cell can cause the values in many other cells to change as well, and this most definitely is the case in the Enclosure project. To illustrate, let's start by expanding out the size of our sheet. As you can see, there are a lot of derived values from our original 4 dimensions. To illustrate, I'm going to greatly change the value of width. If you were paying close attention, you would have noticed that all of the other cells who have names with the word width contained in them also changed. This same convention also goes for the name height. The last 2 of the main dimensions defining the top and bottom depth are less obvious. Still, they also have an effect on the output of our model. Going down column B, the dimensions of wall thickness and clearance are also usually left alone, but may need to be modified due to the type of printer and slicer you may happen to own. For the most part, once these values are set, they are left alone. The last 4 dimensions in column B define the dimensions of the screws you'll be using. These values are available on the internet or in a machinery handbook. Although all dimensions in this sheet are in millimeters, the dimensions for the screw I'm using are for a number 6 screw with 32 threads per inch. You may likely need to change these values to match the screws you'll be using. However, once set, you'll likely be able to just accept these values as default for your project. Let's squeeze this sheet back down so we can get on with creating our enclosure. At this point, we'll want to switch from the spreadsheet workbench to the part design workbench. In the combo view on your left, you're asked to click the Create Body icon. Don't do that. Instead, click the Model view in the combo box, then go to the toolbar and press the yellow icon of the same shape. You'll now notice a yellow icon was created denoting a new part for you. Right-click on that icon and from the menu, click Rename. Rename the part Box Top. Again, click Box Top, then click the toolbar and click the blue body icon. You'll now notice a blue body icon has been created for you. Select the body icon in the part tree, then select the Tasks tab in the combo view. From that menu, click Create Sketch. Now select the Model tab in the combo view, click the arrow in front of the body icon and notice that a sketch has been created for you. This creates the framework for the box top part. We're now going to do the exact same thing to create the box bottom part. While we wait for this to complete, I want to take time to thank all of my channel's new subscribers. I really do appreciate all the likes I've received, but subscribing is the thing that moves me further toward YouTube funding. So if you haven't already, please take time and hit that subscribe button. I do really appreciate it. Thank you. As you can see, we have now created the framework for our box bottom. If you're following along, it's a good time to pick a name for your project and save your work. To continue, expand both the box top and box bottom icons. To get started, we're going to double-click Sketch for the box top. Before we go further, one of the reasons we chose the yellow part icon to begin our box top and bottom is that all elements enclosed beneath that icon enjoy their own personal coordinate system. This ensures that as you change the coordinates for that part, all of its subunits go with it. Anyway, back to our sketch. First, we're going to click the rectangle icon on the top toolbar. Then we're going to drag and drop our rectangle in roughly the center of our sketch. Now we're going to double-click Sketch 001 and do the same thing. Notice that the two sketches overlay each other. Since it would be confusing to have these two parts on top of each other, we need a way to keep them separate. We'll do this by going to the box top part icon and clicking it. Notice that the property value icon in the combo view has changed. On the bottom there are two tabs. We'll select the Data tab. Next, we'll click the arrow in front of the placement property and expand that item. We'll now do the same for the position property. On the value side, we're going to select the Y value. Notice when we did this, a small bluish icon popped up in the entry box. This is the formula editor. Click it. A text box now appears asking you for your formula. This is the beginning of where we start connecting our spreadsheet to our drawing. First, we'll type in the letter S. Notice a drop-down menu appears. We'll select Spreadsheet. After the period after the spreadsheet, we'll type the letters HE. Notice another drop-down menu appears. We'll select height. This is the exact value for the height from our sheet. Rather than stop here, we'll multiply this value by 1.5. This guarantees that our box top and bottom will always be separated by 1.5 times the box height, no matter what we choose height to be. Having done that, we'll now click OK. Notice that one of the sketches appears to have disappeared. It hasn't. It just moved up in our drawing. Use your mouse wheel to zoom out on your drawing. Again, you'll see both of them. Again, double-click on the box top sketch. We'll now center our sketch on the x-axis by clicking 2 endpoints and then the y-axis. Then we'll press the center icon. We'll do this also for the y-axis. Next, we'll select the top line. Notice it turns green. Next, we'll select the horizontal dimension icon. Notice that the length of your line appears dimensioned in red and a combo box appears prompting you for a length. Instead, we're going to select the circular icon to bring up another formula editor. Again, we'll type S and select Spreadsheet from the drop-down menu. You'll next type the letter W and select Width from the menu. Then we'll click the OK button and the OK button on the parent menu. Notice that the size of our rectangle has changed. Again, use the mouse scroll wheel to zoom out and see all of it. Also notice our red dimension has turned orange. This denotes that the dimension is parametric rather than hard-coded. We'll now repeat this for the vertical dimension. Again, zoom out to see your sketch. Everything is now turned green to denote that your sketch is fully constrained. Now in the combo view, click the Close button. Next, we're going to select the model view from the combo box. We'll also select Perspective View from the toolbar. In the model tree, double-click on the box top body label. Then select the pad icon. Next, select the formula editor icon. Again, we'll select Spreadsheet and the depth T alias and click OK. We'll now repeat this same process for the box bottom, with the exception that we'll use depth B to determine the box depth. Again, I'd like to take the opportunity to suggest that you hit that subscribe button in the lower right of the screen. Once I get YouTube funding, the quality and frequency of my videos will significantly increase. If you enjoy and find these videos useful, then please hit that subscribe button. One note, you might have noticed that I have been using depth, as in DEBTH, for the alias name instead of DEPTH. That arose early in the design process in anticipation of an alias name conflict, which never happened. Still, everything worked, so I didn't go back and edit this. Just be aware that I do know that depth is spelled with the letter P. If you've been following along, congratulations. You've just created 2 parametrically defined bricks. Next, we're going to give these bricks some character and transform them into a box top and bottom.